In today's business analytics course, we will understand the calculation of the R square in the simple linear regression. So we understood last time how we can calculate the define the equation, how to frame the equation in the case of simple linear regression, and what are the steps of following or finding out the equation for the independent and dependent variable. So, but the predictive power of the equation, how to determine that the R square indicate the predictive power of the linear equation, how far the independent variable is able to explain the dependent variable that R square used to measure it. So, uh, last time we understood this equation y equal to beta 0 plus beta 1x, but how strong or how accurate this equation is going to predict the values of y by changing the value of x, that we need to understand, that we want to check. And we understood also how we can calculate the how we can frame the equation. So let us take the same example. X and y, the value of x are given 2, 5, 4, 6, 8, and the value of the y is given 40, 48, 32, 64, 56. So we found that beta 0 and beta 1, 37 and 3, and on that basis the regression equations are framed, and the regression equation is this, the regression equation we are finding at the end, y equal to 37 plus 3.3 into x. So this is the way we got a whole calculation in the last steps, and we understood how the whole calculation is being carried out to get the regression equation. And you can put any value. Suppose you want to predict the value of y when the value of x is equal to 80. So then in that case, what we will do, 37 plus 3 into 80. So that value will give us, so 280, 3 into 80 is equal to 240 plus 37 equal to 267. So y equal to 267 when x is equal to 50. So this is the way, the by taking any value, suppose in if you will take the value of x equal to 10, so what should be the value of y? The equation is telling 37 plus 3 into 10, that is equal to 67 only. So let us see, we understood the predictive power and how we can frame the equation when there are two variables and their respective data are there. So let us see the R square. So R square is equal to, if you see here, let us see the R square, how the calculation we can do. So the steps are, here we are understood x and y. So let us first find out the total variance. So the total variance here, the total variance is here, let us calculation. The total variance, all of us know total variance is y minus y bar, then y minus y bar square. So sum of all the y minus y bar square, that is the variance of the data from the mean point. So mean is 52, 40 minus 52 minus 12, minus 4, 0, 64 minus 52 is 12, 56 minus 52 is 4. So y minus y bar square, then we got 320. Then we got the total variance, we got 320. So the variance normally used to be the average variance 320 by 5. But the total variance of the data from the mean is equal to 320. So the predicted value of y cap, if we'll do the calculation by taking 37 and this 3, by taking 37 plus 3 into your this value of then we will get the predicted y. So we got the predicted y also. So now after getting predicted y, let us check how far predicted y is far from the actual y. This is the actual y, this is the predicted y through the equation. So without looking into the value of the y, only on the value of the x, on the basis of this equation I am predicting the value of the y. Can you see the difference? 40, but predicted y we got 43, so that is a difference of 3. Similarly, we got 52 predicted y, but the actual y is 48, so 48 minus 52, this is minus 4. So like this, we got the predicted y and we got the actual y minus y cap is equal to my error. So that is the error that of my prediction. So the equation is able to predict accurately to a level, but still there are some error, and to sum up these error I am squaring it out. So otherwise if you do the summation of all the error, it will be always be 0. So to get rid of this 0 value, what I am doing, to get rid of this, can you see the sum of all the error is always 0 from the predicted. So now to get rid of, I'm squaring it out, I'm finding the error or the unexplained variance is 140 and total variance is 320. So the explained variance will be here, the explained variance is here, that total variance minus the unexplained variance. Total variance is 320 and minus the unexplained variance is equal to your the explained variance. So total variance is equal to explained variance plus the unexplained variance. So the explained variance is equal to total variance minus the unexplained variance. Total variance is 320, unexplained is 140. So taking this unexplained to this side, it will be subtract. So 320 minus 140 equal to 180 for the explained variance. So next, the equation for the r square is equal to 1 minus unexplained variance by total variance, that equal to 1 minus 140 by division 320. So we are dividing 320, then we are getting 0.562. So then you can also do how much this equation could able to explain of the total variance, explained variance by total variance 180 by 320. So 0.5625. If we look into this 0.5625 is nothing but it is the square of the term of the correlation. So correlation is 0.75. So this is nothing but it is just go square of my square of the correlation. So square of correlation 0.5625 and we also got the r square also we got 0.5625. So this is the way. So r square is nothing but the uh, square of the correlation. But if square of correlation is given, r square is given, can you find out correlation? Yeah, so we'll say if r square is given, the square root of r square is correlation. Square root of r square is correlation, but correlation can take negative value, can take also positive value. So if we'll find out, then what is the, should it take positive or negative? So it will take positive or negative value on the basis of your uh, factor of your slope or the regression coefficient. If the regression coefficient is positive, then this will be positive. If the regression coefficient is negative, the square root of the r square, that will give you the correlation with the negative sign. So sine of slope or regression coefficient, then square square root of r square gives the correlation, that will give you the correlation. So this will equal to correlation. Next, what do you mean by r square 0.5625? This is the total variance explained by the independent variable for the dependent variable, that is the variance. So variance or the r square is the total variance explained by the independent variable for the dependent variable, and this is also known as coefficient of determination. Coefficient of determination. So this is the way all of us understood how to calculate r square. All of us last time understood how to calculate the regression from the regression equation from the data, and we have given the steps, and from that we got calculate y cap. Once you calculate y cap, Then on the basis of y cap, how you can find out r square. That the so r square is the way, whether it is a multiple regression, simple regression, this always used to be calculated on the basis of the predicted y and the actual y. And if you draw the graph of these two, so I also calculate the r square value from the data, this from this formula, by going to the formula data analysis and the regression formula in the data regression. So by going to this formula, then also you can calculate the r square by taking the input variable and the output variable. Can you see the input y variable you can take, and here you can take the input x, this variable, then you can see the result. And if you'll see the result, can you see here the r square also directly calculated through this method. If you put OK in the cell where you want to find out result, the cell number 519, we are getting the result. The r square is equal to 5.5625. The way we calculated Excel is showing us some embedded formula and the decoded formula. With that formula, you can get directly r square. Also, can you see the intercept and all, everything is being, this is the result of the your data analysis. You are getting here 3 as the slope, 37 as the intercept. So 3 is nothing but it is a positive change of y by 3 times of the change in the x. So x is changing by 1 unit, y will change by 3 unit. So next, if I'll do a graphical analysis of that data point, so y and y cap on the basis of the given x value. So on the basis of the given x values, here, can you see here for given x, 2, 3, 2, 5, 4, 6, 8. For the 2, it is 40 and 43. So 43 is the predicted line. This is in orange color, and the blue color as all the actual y. So can you see for this is 4, this is 52 and 49. So 52 and 49. So like this, the whole data for 5 it is 48 and 52. So this is the way the predicted and actual. Can you see the predicted y is here? Predicted y here, this data is all about the predicted y, and this data is all about the actual y. And you can see the predicted y is the line, that line is the predicted line, this is the regression line, and the slope of this regression line is 37. Can you see, if I'll then the intercept of this regression line, if I'll draw, and it will intercept with the y-axis at 37, and the slope of this axis is equal to slope of this line is equal to 3. So this is the way, this is the regression equation on the basis of y equal to 37 plus 3x, and these are the predicted number, and this is the way we can do the calculation for the r square. So let us see some of the questions. So we got the value of r square here, the 0.5628. So but the question arises, what is the maximum value of r square can be? So maximum value of r square can be 1. What should be the minimum value of r square? Minimum value of r square will be 0, and the r square can never be negative. It is always positive. It can be lowest, like 0 means the predictive power is 0. If it is from 0 to 5, you can say 0 to 4, you can say mediocre. 4.4 to 0.7, you can say, no, 0 to zero point 0.4, you can say low predictive. 0.4 to 0.7 mediocre. 0.7 onwards. So normally the R square should be more than 0.6, but it varies from industry to industry. In the marketing, if it is more than 0.7, it is good enough. If it is a pharmaceutical quality testing, it's something like a very scientific precision. It should be a 0.9, 0.990. If it is economics or economic predictability, in that case 0.35, 0.45 can also be enough. So it's all depend on the scenario and the context and the different study or the research where you assignment of the day. X is the independent variable and y is the dependent, the same data set. How we can find out r square? You calculate as per the process given in the video, that we calculated r square. Then also you calculate directly through the data analysis formula, and cross check the result. So let us see the next questions. What is the formula for R square or coefficient of determination? What do you mean by the R square? So how do you interpret conceptually? What to calculate, how to calculate correlation from the coefficient of determination? This is how to, not what to. Then interpret the value of R square of 0.6. So you interpret this value. What do exactly you mean by 0.6? What are the minimum and maximum value of R square? So the how to calculate correlation from the R square, how to calculate R square from the correlation, that also you need to understand. So thank you, thanks for your, and just go through some of the industry standard, go through some of the research output, and you keep on interpreting. You can take also the ample of data of your choice of any financial data, statistical data. Now a lot of this biological data also available in the market. So in the case of public health, or in the case of the cost of any business feasibility, and take the data set and do the correlation, and do the regression and find out R square, then you find out how good your equation model to predict the future.